What if I told you the groundbreaking image of a black hole, the one that captivated the world, might be hiding a secret far stranger and more profound than just a swirling vortex of light? Because in 2019, when the world collectively gasped at the orange fiery donut, the first ever photograph of a black hole, M87 Case, something was left unsaid. A subtle truth hidden in plain sight, far more complex than the simple, beautiful spectacle that dominated headlines. This wasn't just a picture, it was a revelation, but perhaps also an abstraction, a carefully constructed window into the universe that showed us exactly what we were ready to see. To understand this, we need to rewind to April 10th, 2019. The world's scientific community, and indeed billions across the globe, held their breath. For the first time in human history, we were about to see a black hole. Not an artist's rendition, not a theoretical model, but an actual image. This wasn't some distant galaxy. This was the supermassive black hole at the heart of galaxy Messier 87, a monstrous object 55 million light-years away, 6.5 billion times the mass of our Sun. The effort behind this image was monumental. It involved the Event Horizon Telescope, EHT, a global network of 8 synchronized radio observatories, effectively turning our entire planet into a single, Earth-sized telescope. Imagine trying to read a newspaper in New York while standing in Paris. That's the kind of precision and power required. For days, these telescopes collected petabytes of data. So much, in fact, that it couldn't be transmitted over the internet. It had to be flown on hard drives to central processing centers. This wasn't just a click of a camera. It was a symphony of data collection, precision timing, and supercomputer processing on an unprecedented scale. When the image was finally unveiled, it was undeniably iconic. A brilliant asymmetric ring of light surrounding a central darkness, the shadow of a black hole. It confirmed decades of theory about these cosmic behemoths, proving Einstein's general relativity in the most extreme laboratory imaginable. The scientific triumph was undeniable, a testament to human ingenuity and perseverance. But even in the moments of awe, a subtle question began to surface for some. How could something so unimaginably distant, so violent, so utterly beyond our sensory perception, appear so perfect? But things took a darker turn, or perhaps a more illuminating one, when we consider what this photograph actually is. It's not like snapping a selfie. The light we're seeing isn't visible light. It's radio waves, incredibly long wavelengths that our eyes can't detect. These waves were collected, thousands of frames per second, for days on end, then painstakingly pieced together using complex algorithms and computational models. This is where the story gets fascinating, because the raw data, if you could even call it a raw visual image, would be nothing more than a chaotic mess of signals. What the EHT team presented was not a literal photograph, but a highly sophisticated reconstruction and interpretation. They used algorithms to fill in gaps, to correct for atmospheric distortion, and most critically, to construct the visual representation from fragmented data. It's a process akin to an extreme form of forensic art, where you're given only tiny glimpses of a face and asked to recreate the full portrait. This isn't to diminish the science, far from it. It's brilliant. But it raises a crucial question. How much human interpretation, how much artistic license is inherent in that photograph? The iconic orange glow. That's false color. The actual radio waves don't have color. The color was assigned to represent intensity, to make the invisible visible, to make the unfathomable comprehensible. And this choice, while scientifically sound, inherently frames our perception. What if the chosen color scheme, or the algorithmic reconstruction, subtly steered our understanding towards something more familiar, more orderly than the reality? Consider the sheer amount of data that needed to be processed and filtered. The black hole's event horizon is a boundary of no return. What we see is the superheated plasma swirling around it, traveling at nearly the speed of light, being warped by gravity so immense that it bends space-time itself. The environment is turbulent, chaotic, and incredibly dynamic. Yet the image presented to the world was remarkably stable, a clear, beautiful ring. Was that stability an accurate representation of that moment in time? Or an average, an idealization constructed from a maelstrom of signals? What they discovered, or rather, what they constructed, forever changed our understanding. But the implications run deeper. The EHT Collaboration had multiple independent teams working in parallel, using different algorithms to process the same data. The remarkable thing is that they all arrived at very similar images. This provides immense confidence in the scientific validity of the image. It suggests that the underlying structure, the ring and the shadow, is robustly present in the data, not an artifact of a single algorithm. However, even with this robustness, every scientific visualization involves choices. Choices about how to render uncertainty, how to represent density, how to color code different intensities. These choices, made by brilliant scientists, are still human choices. They are informed by our understanding of physics, yes, but also by our desire to present a clear, compelling narrative. What if the raw, true data, unrendered and unfiltered, would have been so alien, so abstract, so devoid of relatable form, that it would have been unintelligible to the public, perhaps even to many scientists? What if the perfect image we saw was, in a sense, a translation? A translation from the language of raw astrophysical data into a language our human brains could process and embrace. It allowed us to grasp the impossible, to see the unseeable. But in that act of translation, of simplification, of making it digestible, we may have inadvertently smoothed over some of the true, terrifying complexity of a black hole. To this day, we may never know the full, unvarnished truth of what that raw, fragmented data truly held before it was rendered into the iconic image we all know. The photo of M8070 is an unparalleled triumph of science and engineering. But it's also a powerful reminder that what we see, even through the most advanced instruments, is often a carefully constructed representation. And the true, untamed reality of the cosmos, the chaos and the wonder, might be far more bewildering, far more mysterious than any picture can ever convey. If you want more expeditions into the blurred lines between observation and interpretation, the next video explores the strange case of the impossible exoplanet and what its discovery truly means for our understanding of the universe.